My name is Deb Stockbridge, and I'm a professor at Quincy College. This presentation is for the C++ programming class at Quincy College and anyone else who's interested in learning the C++ programming language. This PowerPoint presentation is based on the 6th edition of Absolute C++ by Walter Savage, published in 2016 by Pearson Incorporated. Chapter 1 reviews some of the basic concepts which you have learned in Introduction to Programming, such as defining variables, assigning values to them, and using them in a program. C++ is a high-level language. It incorporates object-oriented principles. A computer can only understand machine language, which is a low-level language written in binary code. Assembly language is another example of a low-level language. Most of the languages used today are high-level languages, such as Java, C#, and Python. It's necessary to give a name to any storage location which you are using in your program. These are collectively known as identifiers. There are a number of rules for naming identifiers. Keywords or reserved words may not be used as identifiers. The computer distinguishes between capital and lowercase letters, so the names are case sensitive. The name must start with a letter or the underscore and cannot start with a number. Special symbols such as the $ or the exclamation point may not be used in the name. These are some of the common data types. An integer or int is a whole number and typically uses 4 bytes of memory. A float is a relatively small number which includes a decimal point and also uses 4 bytes of memory. A double also includes a decimal point and takes up double the amount of memory as a float, or 8 bytes. A char, or for character, is used to store a single letter or symbol and uses 1 byte of memory. And a bool also uses 1 byte of memory and stores a 1 for true or a 0 for false. The assignment operator is used to store a value in a defined identifier. On the left side, or L value, of the assignment operator, can only be a variable. On the right side, or R values of the assignment operator, there can be a variable or an expression or a literal value. The value on the right must match the data type of the value on the left. So amount divided by charge must be the same data type as amount because it is assigned to amount. Many times when you have division, the result is a double. So you want to make sure that the variable which you are assigning it to is a double also. Shorthand notation, which is shown here as well, can be used with the assignment operator. On the left is the shorthand notation, and on the right is the longer version. Backslash is used to create an escape sequence in which the symbol following the backslash has a new meaning. For example, \n means to go to a new line. 2 backslashes print 1 backslash. Backslash single quote prints a single quote, and backslash double quote prints a double quote. A constant cannot be changed when the program is running. In the example shown on this slide, interest is a constant. Typically, constants are typed in all capital letters. They also must be given a value when they are defined. This slide shows an example of integer division. An important rule is that an integer divided by an integer gives an integer as an answer. So 17 divided by 5, 3 is your answer. You can capture the remainder by using modulus. To make sure that you do not lose data with integer division, you can add a decimal point and a 0 to make the integer into a double. And just going back to that modulus one, so 17 modulus 15 is 2. because for integer division, when we have put 3, it's 15, and then 2 is left over. Static cast can be used to change the data type of a variable or the result of a calculation while the program is running. In this example, we have num1, which is 17, plus num2, which is 5, that yields 22, and then using the static cast double, that changes 22 to 22.0. The increment and the decrement operators either add 1 to a variable or subtract 1 from that variable. You will find these very useful when we are using loops. If the operator being the plus plus or the minus minus, is in front of the variable, it is known as the pre-increment or pre-decrement operator. And if it is after the variable, it is known as the post-increment operator or the post-decrement operator. Whether to use the pre-increment or the post-increment does not matter until you involve the assignment operator. In the first example, which is number is assigned to count plus plus, the first thing that happens is count, which has been given a value of 2, is assigned to number. So number is 2. Then you increment count, so count becomes 3. In the second, where you're using the pre-increment operator, the first thing you encounter are the plus plus. So first, that is added to count. So count becomes 3. Then it's assigned to number. So number would also be 3. Now we'll get into some of the fun things about programming. This slide shows a typical first program. In the C++ library called IOStream, there are instructions for how cout and cin are used in a programming. Using namespace std shows the location of the IOStream files. You'll use those 2 lines on many programs that you're writing. The most important function is the main function. It is listed as int main. The int means that it will send an integer to the compiler if the program works correctly. That is why you see return 0 at the end of the function. 0 is considered an integer. In this case, hello world will output and be shown on the monitor. There are also curly braces which encompass the executable instructions in the program. Hello world is considered an executable statement, and you have cin, and the 2 arrows after cout are the insertion operators, and they are always used with cout. This slide shows a short example of a program that uses the string data type. Whenever you're using a string data type, you need to have pound include string as one of the pre-processing directives. We always use the pound include IOStream, which gives the information on what cout means, and using namespace std shows where you could find that in the library for the compiler. You have your int main function and your curly braces above and below and surrounding the executable statements. So the first thing you do is you have a variable named fname, and it's a string data type, and you're assigning it the name Joshua. Any strings should be surrounded by double quotes. And then, of course, every executable statement needs to finish with a semicolon. You're also, the next line, you're assigning Patel to lname. And then one of the interesting things about strings, they have a number of ways of adding strings together, and one of them is to use the plus sign. So when you have cout and then the insertion operator, those 2 arrows, fname plus lname, what it will do is print out both those names together. Unfortunately, there will not be a space. You would have to add that space in as part of your coding. Formatting the output is very important. When using the formatting tools listed on the slide, you need to use #include iomanip. Set IOs fixed and set IOs show point. Make sure that the decimal point is shown in the output. Set precision lists the number of numbers which will appear to the right of the decimal point. In this example, there will be 2 numbers to the right of the decimal point. This next slide talks about using CIN. So CIN uses the extraction operator, where the arrows go the opposite way from the cout, which is used with cout, which is the insertion operator. So this is an example where we have a prompt. So our prompt is the cout line that says enter a number. So just going back to review everything, before you can use a variable, you need to declare it. So we have a variable num1, and that's a double. Then we say, ask the person at the computer to enter a number. The computer will wait for that person to enter the number. When they enter the number and press either enter or space bar, then that whatever they put in will be assigned to num1. And then on your cout statement, you have your number times 2 is, and then notice there's a space between the S and the quote. That leaves a space before that next number will appear. And you can have a string of these or a number of these insertion operators with just using one cout, which is what you have on the second line there. I haven't needed to include cout again because it's really still in that same process. I just ran out of space. So we have, it takes whatever the person put in for num1, multiply it by 2, and it will output that.